honey.
Hi.
What are you doing there, kiddo?
I'm trying to visualize something. It's like trying to figure out what a sand in a conical pile would look like.
A what?
Like sand in a cone-like shape. It's calculus.
This is why I was an English major. Good luck, kid.
Thank you. Now you may be wondering how I ended up pouring kitty litter through a funnel on my dining room table. Well, it all started the day before when I got something in the mail. Alright, let's see what we got here. Nothing. Christmas cards, I guess. Or birthday cards? It's a little late, I guess. They're for my mom. Birthday was in October. More stuff. Okay. This looks like bills. Something to do with the Easy Pass. Junk mail. New Jersey natural gas. Blah, blah, blah. Okay. What's this? That's strange. Oh, important. Okay. Okay. What? Hello, friend. Hope your day is as sweet as a summer day. That your loved ones are safe. I'm sure you'd like them to stay that way. So, my friend, you can make sure it stays that way. Or you can jeopardize them if you wish. What the heck is this? To keep them safe, you'll have to do something for me. What a fun game for me. Enclosed is a problem, a riddle even, that you need to solve. Okay. Oh dear. You have 2 days. Timer starts now. Good luck, friend. Contact the police and your life will cease. Oh, trying to rhyme, I see. Okay. The Riddler. Spelled with 3 D's. Please don't sue me, Warner Brothers. Okay. Oh, contact me at thatriddlerguy@yahoo.com. Great. Okay. All right, let's see. What do we have here? The riddle. Sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. The diameter of the base of the cone is 3 times the altitude. At what rate is the height of the pile changing when the pile is 15 feet high? Okay, well, I guess it's a good thing that I know calculus, I suppose. Alright, I just finished up all the math. I put it all together for him. Nice little cohesive video. Only time will tell what'll happen. I'm about to send over the video, and I guess we'll see what happens from there. I really don't know why he couldn't have done it himself. It was really just like a simple related rates problem. He also could have used the internet. That's probably easily to his access. I'm assuming supervillains have access to Google. But, it's possible that, he's his strong suits aren't math or using Google. I guess they're riddles, since he's the Riddler, I would assume. I guess that's besides the point, really. I'm not going to waste that much more time. I'm just going to send over that video, and hopefully I can move forward from this, and we'll all be fine, hopefully. I can't believe this happened. So I have the final email here ready to go. It's addressed to thatriddlerguy@gmail.com. I tried the @yahoo.com, but I got nothing back. So I don't know if that's an outdated email or what. If the @gmail account doesn't work, I'm not sure what I'll do. So I'm really hoping that this works. So I'm gonna send this email over now. So hopefully it all works out. Here was the final video. Some good things to know before we start. What is a derivative? A derivative is the instantaneous rate of change at a given value of a function. Differentiation is the process of finding the derivative. Some helpful rules to know. The power rule. This rule states that the derivative of a variable, like x raised to some degree, n, is equal to n times x raised to the power of n minus 1. The constant multiple rule. This rule states that when finding the derivative, if there is a constant multiplied by the function, the derivative is equal to the constant times the derivative of the function. Here we have sand falling off a conveyor belt and onto a conical pile. It's falling at a rate of 10 cubic feet per minute. This rate of 10 cubic feet per minute is the rate of change of the volume. We know this because as the sand falls into a pile, the entire pile gets larger, the height and the circular base of the pile. Another giveaway is the units, which are cubic feet per minute. When a unit is cubed, it's most likely referring to volume. Also given that the diameter of the base of the cone is 3 times the altitude, or height of the cone. And given that information, it's our job to figure out the rate at which the height of the pile is changing when the pile is 15 feet high. So let's set up some variables. H is height in feet, D is diameter in feet, which is also equal to 3 times the height, V is volume in cubic feet, and dV dt is the volume's rate of change in cubic feet per minute, which is given to be 10 cubic feet per minute. We're looking for dH dt, or the rate at which the height of the pile is changing in feet per minute when the pile is 15 feet high. So let's set up an equation to connect these variables using the volume formula of a cone, which is volume equals pi times radius squared times height times 1/3. We're going to replace the radius squared with half of the diameter squared because radius is equal to half of diameter. So we end up with the equation volume equals pi times 3/4 times h cubed. Since we're looking for rates of change, we're going to differentiate both sides of the equation with respect to time, which will allow us to find the instantaneous rate of change of the pile's height when the pile is 15 feet tall. We can substitute 10 for dV dt because we're given that the rate of change of the volume is 10 cubic feet per minute. And now we can finally substitute 15 for h. The height of 15 is not a constant since the height of the pile is constantly changing over time. Because of this, we can only plug in 15 after we've differentiated the equation. Now that all that scary calculus is over, it's time to simply solve for dH/dt. Your final answer will be 8 over 405 times pi feet per minute. So, I got a response from him. And according to him, my family and I are safe. Until then, which I hope there is no then. I'm glad, that we're all safe and okay. I can't help but wonder what started all this in the first place, but, I guess all's well that ends well, right? I just hope I never have to contact this off-brand Riddler again. One can hope.
Okay. Dr. Wilson. Dr. Wilson. Dr. Williams. I care about my employees. See, I know your name. I got a new idea on how to stop Batman. Goes like this. So, we got a conveyor belt happening here. You can tell it's a conveyor belt because I said so. Now, on this conveyor belt, there's going to be a lot of sand. Don't worry, I'll outsource that. You don't have to worry about getting the sand. I'll do that. So, basically, you have the sand here, and there will be a hole. Batman is going to be in this hole. You can tell it's Batman because of the pointy bat ears. Batman is sat here because he's helpless and he's about to be crushed by a bunch of sand. So, I'm going to demonstrate that now. The sand is going to fall and crush him. It's going to form a cone-like shape here. But here's where you come in, Dr. Williams. I want the volume of this pile of sand to change at 10 feet cubed per minute. I want that. I want that because I said so. I'm the villain in charge here. I pay you. You do what I want. In addition to that, this is also very crucial. I want this part down here, the sand. I don't know what you call that. Darn it. William, we need to get this fixed. Can you tell here that I'm improvising with this? Trying to keep this darn thing. I'm sorry, Dr. Williams. That outburst wasn't directed at you. I have a lot on my plate. I really do. I've had a lot on my plate lately. But back to Batman. Like I was saying, it's 10 feet cubed per minute. I want that. I want that to be how the volume of the pile's changing. I also want this part down here, whatever you'd call it, the width, the diameter, whatever the mathematical term. I want this down here. I want it to be 3 times the height, okay? So whatever this is up here, I want it to be 3 times that, so, I don't know, diameter can equal 3 times the height. That's what I want, Dr. Williams. And I need you to do this for me. I need you to figure this out, you know? You're the brains, well, you're part of the brains of this operation, Dr. Williams. You know, you get the easier part, I suppose. I come up with the ingenious ideas, you do, just, you know, you do the math, which is important, you know. I do the riddles and I come up with all the good ways to trap Batman. And, you know, you figure out, you know, the volume of stuff and what poisons are best for me to use. So, you know, you're an important asset. Not someone I couldn't replace, of course, but you're important. Did you catch that? You got that, Dr. Williams? You got that? What do you mean? What do you mean you can't help me right now? You're on an all expenses paid cruise? What are you talking about? I don't remember approving your time off for that. What do you mean I approved it? Check my email? Fine, I'll check my email. Give me a second. Hold on. Mr. Williams. Batman is bad. Hold on, I'm signing in. Okay, let's see. Okay. PTO. All right, Dr. Williams. It may appear that I approved your time off. So, well, what am I supposed to do then? Dr. Williams, what do you want me to do? What should I do? Dr. Williams, what am I supposed to do? I can't figure this out. Batman's not going to figure this out. I'm sorry. Sorry about that. Let me just remember, I need to take a breath. I just need to remember what my anger management counselor told me. You know, taking deep breaths, counting to 10, and all. Sorry. Now, what was it you were saying? Calculus? I don't understand calculus. Dr. Williams, you know I don't know how to do calculus. Okay, you can tell me it's the mathematics of change. I get that you're saying that doesn't mean anything to me. I don't know what a derivative is or what differentiation means, okay? You're talking in a whole nother language to me I do not understand. But, Dr. Williams, I think I might be able to find someone who does understand. What do you mean, what do I mean? You were in high school once, weren't you? Weren't you a victim to that calculus class that some people take, even though many live to regret it? Didn't you take that challenge? You put yourself through that? Well, I know that there's some other high school student right now putting themselves through that same challenge. Personally, I did not do that. You know, I heard horror stories about calculus. I didn't want to pursue it. But I know there's someone out there, some unsuspecting high school student. So, Dr. Williams, enjoy your trip. I'm gonna go strike fear into the heart of some high school student. And I'll get my results. I'll get them. You enjoy your vacation, okay? I'll see you.